Hello students, today we'll see a very interesting topic, the formation of ions. In this class, we are going to learn everything about the ions, right? So I recommend that I suggest before watching this lecture, you watch the first video lecture in this series, right? This is basic chemistry lecture 2. Fine. Formation of ions. So before seeing the formation of ions, we should know what are ions, right? Remember that ions are any charged atoms or molecules. Any atoms which are charged or any molecules which are charged are going to be called as ions. First thing we already know, the one basic thing we already know is that a charge can be of two types, right? You can have just two types of charges, right? Either you have the positive charges or the negative charges. There is no third kind of charge, right? Whether positive charge, something can carry the positive charge or negative charge. So if some species are charged, there are just two possibilities, right? Whether it can be positively charged or negatively charged. So based on this only, the ions can be of two types. The positively charged ion or the negatively charged ions, right? There is a term for positively charged ions. It's called cations. The positively charged ions are called cations, and the negatively charged ions will be called as anions. We'll keep this in mind. These terms will keep this in mind, that the positively charged ions are always called cations and the negatively charged ions will be anions. Fine. If you have to take an example, Na plus, what do you see? Sodium is carrying a positive charge over it. Remember, the positive charge will always reflect over here on the right hand side, upper side, right? So sodium we see carries some charge. So first thing is very clear to us that this is a charged species or charged atom. So this is ion. Which ion is this? Since this is carrying the positive charge, so it's a cation, right? Mg plus 2, cation. NH4 plus, it's a cation, right? Now, etc. For the negative ions, examples can be taken as O minus 2. Oxygen over here is carrying negative of two charges, so this is a negatively charged ion. F minus, etc. Right? Now, so in this particular lecture, we will be talking just about the atoms and their ions, right? Just the atomic ions we are going to see. So let's suppose over here, one thing we need to keep in mind that we are going to talk about the relative charges. We need to keep in mind about the relative charges of protons and the electrons. So proton carries a relative charge of +1 and electron carries a relative charge of -1. We know that. One proton +1, one electron -1. Now, we are going to assume different scenarios over here. So let's assume scenario number 1. Now here is a person, we have a person over here. Correct. Now, just assume in his right hand, he is carrying 5 protons and in his right hand, he is carrying 5 electrons. Just assume that. So can I say that his right hand carries +5 charge? Because one proton carries +1, so 5 proton carries +5, and his left hand carries -5 charge, right? So if I talk about this particular person, his right hand carries +5 and his left hand carries -5. So if I have to talk about the total charge that this person is carrying, is that +5 plus -5? If you have to talk about the total charges, it's the charge in this hand plus the charge in this hand. Does it give 0? What do we say over here? That this person carries 0 charge. Let's assume that, let's replace this person. Let's assume that this person is an atom, right? Neutron does not have any role in the charge. That is why we are not considering neutron over here. Fine. Now, this person carries, when it carries 5 proton and 5 electron, the total charge that this person carries is 0. If we replace this person with an atom, if an atom contains 5 proton and 5 electron, the total charge over the atom will be 0. And anything, any atom or any chemical species which carries a 0 charge is called neutral. It's not an ion, we know that, because ions are charged species. The net charge, there will be some net charge over that, and we'll see that soon. Fine. This is situation number 1. Let's talk about the situation number 2. Now, it's the same person over here still have 5 protons, but this time he has 4 electrons. E minus is electrons, P is protons. So because of 5 proton, does his right hand carries plus 5 charge and his left hand carries minus 4 charge, right? If I have to calculate the total charge that this person is carrying, is it plus 5 plus of minus 4 equals to plus 1? Right? So now in this particular case, this particular person is carrying a net charge of plus 1. Right? Fine. Now, in this case, if you replace this person with an atom, is this atom neutral anymore? No, this atom will not be neutral anymore because it is going to show a net charge of plus 1. So has the atom become ion? Yes. Which ion it has become? Of course, the positive charge, so cation. Right. Now let's consider the third case. Let's take third case over here. The same person, this time he carries 5 proton but 7 electrons on the left hand. Now, because of 5 proton, he carries plus 5 charge on his right hand and minus 7 charge because of 7 electrons in his left hand. If you have to calculate the total charge, you will find it's plus 5 plus of minus 7 equals to minus 2. In this case, this person is carrying a net charge of minus 2. If you replace this person again with an atom, this atom, if it contains 5 proton and 7 electrons, it is going to show a net charge of minus 2. Again, it's not a neutral atom because it's showing a net charge, some net charge, right? Which is not 0. So it's a case of ion. Which ion? Since it is showing negative charge, so it's an ion. Correct. Now, what did we see? Okay, this scene is very clear to us. In the first case, what did we see? When they had the equal number of protons and electrons, the total charge was 0. When there was more number of protons with respect to electron, the charge developed was plus 1. When there was more number of electrons with respect to the proton, the negative charge developed. Or if you have to just compare case 1 with the 2 and 3, you see that in 2 and 3, the number of protons and electrons are not equal, right? We'll take one more scenario, the general case. So general case, we are taking scenario 1. A person, right hand carries x number of protons and the left hand carries x number of electrons. Because of x proton, we'll have plus x charge. Because of x electron, we'll have minus x charge. If we have to calculate the TC, which is the total charge, TC is total charge over here, will it be plus x plus of minus x equals to 0? This person over here, or this atom over here is neutral. It's neutral because the total charge is 0. Now, second case, the same person over here, he carries x number of proton and x minus n number of electron. That simply means the number of electrons is lesser with respect to the protons. We can see that, right? It contains x number of protons and it carries x minus some number, x minus n number of electrons. Of course, n will be integer, right? So, okay. If you have to calculate the total charge over here, because of x proton, you will have plus x charge. Because of x minus n electron, you will have minus of x minus n charges. Right? Now, total charge will be plus of x minus of x minus n. Correct? If you calculate this, you will find the total charge over this will be, just a minute, there is a mistake over here. Sorry, there is a mistake over here. Okay, total charge will be the plus x plus of minus of x plus n, right? The total charge, the charge because of protons and plus charge because of electrons. If you solve it, you will find the total charge over the atom will be plus n. In this case, the atom becomes a cation, right? Now, let's take one more case, the third case. There are just three possibilities. One possibility when the protons and electrons are equal in numbers. Second case, when the number of electrons are lesser than the number of protons. And there is a third case when it's quite evident to you all. You have x number of protons, but x plus n number of electrons this time. This time you have more number of electrons with respect to protons, right? So because of x protons, will you have plus x charge? And because of x plus n electron, will you have minus of x plus n charge? The total charge, if you find out over here, will be x plus minus of x plus n. It will give you minus n, right? So here, the net charge over the atom will be minus n. So we'll say that it's an ion. Now here we are about to draw an important conclusion, is that you see that whenever the number of protons and electrons in the previous page also, on the previous page we saw that when they had 5 protons and 5 electrons, the charge was 0. In the general case also, when we saw that when they have equal number of protons and electrons, atom is always neutral. When the number of electron is lesser than the number of proton, it becomes cation. Or when the number of electron is more than the number of protons, it becomes anion, right? So we are going to draw this conclusion over here, is that atom is neutral. But when number of proton is equal to the number of electrons. Remember, this is the case. This is the only case when an atom will be neutral, right? If an atom does not show any charge, in that case, the number of protons must be equal to the number of electrons. For example, let's take this example, O816. First thing, 8 is the atomic number. We know that. 16 is the atomic mass. We have already discussed this in lecture 1 of this series, right? Okay. Now, do we see any positive or negative sign over oxygen? No, we are not seeing any plus or minus sign over the oxygen. That means oxygen is neutral. That is how you identify whether some atom is neutral or not, right? You just have to look out for the sign, the positive or negative sign over the atom. If you don't find any sign, it's neutral. Fine. If it is neutral, first thing, can you tell me how many protons are there? Is the number of protons equal to the atomic number 8? Since this is neutral, so number of electrons must be equal to the number of protons. And so the number of electron is also 8. Correct? Another example, let's see quickly. Fluorine, 9 and 19. Atomic number is 9. Fluorine over here is neutral because we don't see any positive or negative sign over the fluorine, right? So atomic number is 9, so number of protons is 9. Since this is neutral, so the number of electrons should also be same, 9 only, right? So in case of any neutral atom, in general, if you take a general example, if this is Xg, A, this is how we represent generally in any atom, right? G is the atomic number. There is no positive or negative sign over the X if X is neutral. In that case, can we simply say that number of protons will be equal to the number of electrons? That is the condition for anything to be neutral, right? So number of proton is equal to the number of electron, but what is the number of proton? Is it equal to the atomic number? Right? So number of proton will be equal to number of electrons, and that will be equal to G, atomic number. Fine. So here we are going to say that we have already seen in the previous lecture that atomic number is always equal to the number of protons. We have seen that, right? But remember, when it any atom is neutral, whenever any atom is neutral, in that case, atomic number will of course be equal to the number of protons. This will always be the case, doesn't matter whether it's an ion or not. We'll see that soon. But it will also be equal to the number of electrons as the condition would demand, right? According to the condition for neutrality of the atom, number of protons must be equal to the number of electron, and that should be equal to the atomic number. This particular case you are not going to apply on non-neutral atom or ions, right? In case of neutral atom only, this is for neutral atoms strictly. We'll say that number of protons will be equal to number of electrons, and that will be equal to the atomic number just for the neutral atoms, right? This is universal. This is true for whether it's ion or neutral. But this particular thing, this number of protons equal to number of electrons, will just be for the neutral atoms, right? Fine. So first thing we saw that any atom is neutral when number of proton is equal to the number of electron. Now, in scenario 2 and 3, if you check, in scenario 2 and 3, what do we see? That the number of protons and electrons are not equal. In one of the case, the number of electrons are lesser than the number of protons. In another case, the third case, the number of electrons is more than the number of protons. We saw it in the previous page also, right? Here also we saw. When you had 4 electrons and 5 protons, that means unequal number. The protons and electrons are not equal in number. They form ion. In this case also, we saw that when the proton and electrons are not equal in number, it becomes ion, right? What type of ion it becomes, we will discuss it soon. Fine. Now, so can we simply say that in case of ions, can we simply say, learning from those two cases, case number 2 and case number 3, can we simply say that in case of ions, the number of protons will never ever be equal to number of electrons. Number of protons and electrons will be different for ions. This is the condition for any neutral atom to become ions, right? We will learn about that. Fine. Okay. So this is the fact that atomic number will always be equal to the number of protons, but this will never be equal to number of electrons. Keep that in mind. Fine. So for example, if I say Na plus 1, atomic number 11, atomic mass 23. So if I ask you atomic number, it's of course 11. That's quite evident. If I ask you number of proton, that is equal to atomic number 11. But if I ask you, is number of electron equal to 11? No. Number of electron is not equal to 11. What is the number of electron? We'll learn soon how to find out. Fine. But number of electrons is not 11 in this case, right? So what did we see over here? This particular thing is not working for the ions. This particular formula will work just for the neutral atoms. Fine. Okay. Remember one more thing is that this is an important note, that in any chemical reaction, if I say a chemical reaction, I am referring just to the ordinary chemical reaction. Just for the ordinary chemical reaction, remember that nucleons never participate. In any normal reaction, the nucleons, which means protons, that means simply nucleons are protons and neutrons, they will never ever participate in the ordinary reactions, correct? So can we say that, from this, can we say that the number of protons and number of neutrons of an atom remains constant during the course of reaction? The number of protons and neutrons will never change for an atom for the ordinary reactions, right? Their number changes just in the case of nuclear reaction. As the name suggests, nuclear reaction means the nucleus participate. Nucleus participate means whoever lives in the nucleus, they are protons and neutrons, right? So keep in mind, in the normal reaction, ordinary reactions, nucleus never participate there, right? Okay, so did you understand that if the number of protons and neutrons are not changing, and we know that atomic number is equal to the number of protons, so can we also say that atomic number remains constant? Atomic number will not change, right? One more thing, we also know that A equals to atomic number plus number of neutrons. Since the atomic number is not changing for the atom for a chemical reaction, in a chemical reaction, number of neutrons is not changing in a chemical reactions, so the sum will also not change. That means A will also not change. So can we also say that mass number also remain constant, right? Now the question is, then what participates? If the protons and neutrons are not participating in the chemical reaction, then which particle, who is participating in the chemical reaction, who is driving the chemical reaction, right? So remember this, just the electrons, that too the valence electrons. What are the valence electrons? We'll learn in the next video lecture, right? Okay, so just the electrons, more precisely, just the valence electrons participate in a chemical reaction. We'll keep that in mind in a normal chemical reaction, of course, correct? So just the electrons, or the valence electrons to be more precise, will participate in a chemical reaction, right? So can we just, from these two statements, this one and the previous one where we said that the number of nucleons will not change, can we just say that we cannot interfere with atomic number or atomic mass of an atom, of course, unless a case of nuclear reaction, right? Which we are going to study in later classes, right? So we cannot interfere with the number of atomic with the atomic number or atomic masses of an atom during a chemical reaction. All you can do is just interfere with number of electrons. You can just change the number of electrons, but you are incapable of changing the number of nucleons. Do keep that in mind, right? So for example, if I have to take sodium and suppose that sodium forms Na+, of course sodium ion will form from the sodium atom only, right? So this is sodium. If its atomic number is 11, its atomic number is also 11. Atomic number will not change. If its atomic mass is 23, Na+ also has the same mass number, 23 only. What did we see over here? That the protons did not change. That means atomic number did not change. The atomic mass also did not change, right? They will remain constant during a course of reaction, right? Formation of ion is a part of chemical reaction. Do know that. Fine. Fluorine, if it becomes F-1, fluorine is 9, atomic number 9, atomic mass is 19. You have to memorize the atomic number and atomic mass. Do keep that in mind. Till atomic number 30 at least. Fine. So we see that again, that atomic number of fluorine is not changing, neither the atomic mass, right? So in these two cases, in any case wherever the ions form or the atom participate in the chemical reaction, you will see that atomic mass and atomic number never changes in normal reaction, correct? Correct. Now, if I have to talk about the number of electrons in the first case, is the number of electrons over here 11? Because sodium over here in the first case, here, is it neutral? Yes, it's neutral. So number of electron must be equal to the number of protons, which should be equal to the number of, atomic number. But in this case, this is ion, and we know that the number of proton is not equal to number of electrons. So of course the number of electron is no more 11. We see number of electrons have changed, right? What is the number of electrons? We are going to see in the next lecture. Fine. Now in this particular case also, number of electrons is 9, because fluorine in this case is neutral, but here it's not neutral, so number of proton is not equal to number of electrons. Number of proton is not equal to electron. In this case also proton is 9, in this case also the proton is 11 only. You see, protons and neutrons are not changing, just the number of electrons changing, right? Fine. In the next class, in the next video lecture, we will be dealing with how actually the ions form.